Hi folks, this is the video tutorial for chapter 3 of my textbook on using 3D experiences composite finite element analysis. Now, the method, the geometry that I'm going to take is not much different from the one in chapter 2. However, the approach that I'm going to take in creating the finite element model is going to be based on zones and laminates. We did it based on manual ply creation in chapter 2, and this is different. So here's the idea. Uh, if you have a composite plate and you have to uh, have a thick section and a thin section, this has 4 plies and this has 2 plies. It is a bad idea to suddenly drop the thickness from one section to another section. It is much better if you gradually drop it, and this gradually dropping is called the drop-off zone or drop-off section. So this is much better for preventing delamination, some of the other failures that are associated with composites. Okay, so I want to show you how to model this problem based on creating basically 3 zones. Zone 1 is the thick zone, zone 3 is the thin zone, and the middle was a transition zone. The material properties are of that of carbon epoxy, and the information is given here. Now, as far as the geometry goes, it is let's say it is 100 millimeters this way in the direction y, and 120 millimeters in the direction x. The edge that's on the y-axis is all clamped, okay, and on the on this axis here, on this line here, it is subjected to a tension load of 10 Newton per millimeter. Now, generally speaking, it may be difficult to decide whether one have finite element symmetry or not. But in this problem, because we have 90s and zeros as plies, namely cross plies, it is not hard to see that this plane, the XZ, is a plane of symmetry. Okay. Therefore, instead of modeling this whole 200 millimeter by 120 millimeter, I'm going to model half of it, which is 50 millimeter by 120. Of course, the edge on the y-axis is clamped, and the edge that is artificially introduced by the XZ plane, cutting it by the XZ plane, it has to be restrained according to rules of symmetry for shells. And these are the conditions, okay? All right, so let's go ahead and model this thing. The one difference between this problem and the one that I did in chapter 2 is that in chapter 2 I created the material first. Okay? I showed you how to create the material first and then go and create the model. The geometry here, I'm going to do it in the reverse order. There's some subtle issues associated with that. Okay, so this is, I'm going to go, I've gone into a generative shape design because the geometry is just a surface. So, and I'm going to change the name of this thing, right click properties. I'm going to call it a video chapter 3, video chapter 3, chapter 3, and composites. Giving it proper names is a good idea because in 3D experience, you're dealing with not a file system, but a database system, and your database is usually on the cloud, and you should be you have to go there and search for your parts and simulation, etc. So it's much easier if you give it a name. Apply, okay, and immediately I'm going to save this thing. This is saved for me on some server in on the source systems. Okay, so let's on the horizontal plane, I will sketch a rectangle which is 120 millimeters long along the x-axis and 50 along the y. Okay, let's dimension these things. Okay, so this is going to be 120. and this one is going to be 50. Okay, we exit, and I will fill this thing, F-I-L-L, with a surface. Okay, now this fill is going to be the entire rectangle, as you can see. So what I'm going to do is I will create two planes at different location. One of them is 60 millimeters away, offset from the YZ plane, and then another one 90. And these are the planes that are going to be used to cut the surfaces, this surface with it, and create the other uh, pieces. So basically, I want to take that rectangle and cut it into 3 pieces. Okay. So in order to do that, there are different ways of approaching it. But what I'm going to do is I'm going to create 2 planes, offset from this plane at a distance of 60. Okay, there we are, plane 1, and then another one offset of 90, which is another 30 millimeters away from the one that we just did, 90. So these are the 2 planes. I'm going to cut my surface with these things. Okay, so let's save everything. So we're going to get the split, and the split is under transform, and there it is, split. Okay, let's see now. It says element to cut is that surface, that fill, and the cutting element is that first plane. See that right there? And it will tell you that there are actually two pieces involved here. We're going to say keep both sides. Okay, so if you look at your tree, this split one is basically that thick section. Okay, so I'm going to rename this thing. Right click, properties. I'm going to try to do this thing as much as I can with the notation used in the textbook in that chapter. So I call this thing thick section. Okay, thick section. Apply, and okay. Oh, I think let me try it again. Properties, thick section. Apply. Oh, maybe just a second. Right there. This is what I wanted to call a feature name. Thick section. No, by mistake, I renamed this guy. Okay, so thick section, apply. Now it's correctly changed. I'm going to let me go ahead and this other guy that I changed the name, which is right here. I'm going to call it. I'm just going to leave it alone. So the part. Okay. Here, see the name of this name was changed. I didn't mean it. So the part. Okay, good. And feature thick is the spelling is not correct. Thick section. Apply. Okay. Oh, there we are. Right there. This I'm not going to change it. However, I will cut that piece, split 2, with the plane that I created. So split. It says element to cut is that split 2, and the cutting element is that plane, second plane. And again, we're going to keep both sides, and we say okay. Now we're going to do some name changes here. Okay. Notice that there is this guy, which is going to be the thin section. So right click, properties. Yep, that's going to be the thin section. Okay, apply. Notice that it did change. Okay. And this fellow is the transition section or the drop-off area. So right click, properties. I'll call it transition section. and apply, and OK. Now, the other thing I'm going to do is I'm going to extract the boundaries of the thick section, transition section, and the thin section. Okay. In order to do that, you go to I think it's under let's see now under let's try transition. That's fine. See if we can find a boundary. Oh, right there, boundary. Click on it. All right. So first the thick section. Okay. And of course, I'm going to give it this name. Okay, so say OK. And where is the boundary? Right here. Right click properties. And I'm going to call it boundary of thick section. How about that? Boundary of thick section. Apply. You can see that right there. And then do another one for the middle one. So boundary of this guy. Say OK. I'm going to call this thing boundary of the transition section. Boundary transition section. Apply. Right there. And then get the boundary of this guy. Right there. Say OK. And this is going to be boundary of the thin section. I'm trying just to get organized, that's all. Thin section. Apply. Right there. And OK. All right. So let me see for a second. What I need to do is, because I'm going to need a rosette, I have two choices of doing it. One I can create a rosette right here. See under Essentials, you can go and create the access system and then use it later. That's one option. Or I can also create a rosette later on. So let me do that right now. I think yeah, I think in the book I did it later. Okay. In the book I did later, I'm going to do the same thing here. So we're done. Save this. All right. Now we're going to go and create our material. So we go to the tools under material browser right here. Expand this thing. See, say create a material. Okay. First of all, the title, I'm going to call it video. Video chapter 3. Chapter 3, composites. Okay. And here, you just have to make sure that both composite domain and simulation domains are checked. Okay, so that's pretty much it. So we say OK. All right. Notice that in your material database, this is going to be created right here. See that? Video chapter 3 composite. We're going to say right click, apply. I'm going to close this box, and I'm going to apply it to my part, and I say OK. This is just a placeholder, so now I have to fill in the placeholder right there. Notice that the material composites domain is here. Double click on it. The only thing is that the thickness, the cube thickness is 0.75 millimeter. I think I had it in the transparencies. If not, please make sure that, well, it's stated in the book, 0.75 millimeter. There's nothing else to input there. Incidentally, let me double click on this thing again. This is actually not bi-directional, but changing this has no effect. However, it affects the bill of material if you ever have to make one. So I'll make it unidirectional, okay, as I intended to be. Now we're going to double click on material selection, material simulation, and we go to structures, abacus multiphysics, mechanical, elasticity, elastic, okay, and under the pull down menu here we use lamina, okay. Now the properties that I want are stated in the table here. Where's that? Right there, these values. So let me make sure that I have it in front of me. Let me get it from myself on the other my other laptop so that I know what I'm doing. Let me see for a second. Sorry, just bear with me for a second. Okay. And yes. So let me minimize this. E1 is 133.86, 133.86 MPa. E2, the transverse direction, Young's modulus and transverse direction, or modulus and transverse direction, 7.706 MPa. Poisson ratio is 0.301. For this G is 4.306, 4.306 GPa. Same thing here, 4.306 GPa. I'm sorry, not GPa, MPa. Yeah. And this one is 2.76, 2.76, oops, 2.76, 76 MPa. Actually, these were all wrong. This is GPa. These are all GPa, not MPa. I'm going to change that right here. G. I did not read my cable correctly. G. And G here. Okay. All right. Correct. Now, if you want to input the strength properties, and I do, so I have to go to damage here under fiber reinforced composite and under fail stress, and I put the strength properties for my from my table, the second column basically, and those are in MPa. Okay, so this first one is 1830 MPa, 1830 MPa. The other one is negative. You remember, if you don't put a negative here, it will tell you that it should be negative, but it will run. Okay, so it'll give you a warning message later on. So I might as well put it in there, 1096, minus 1096. For the transverse direction, this is 57. And for the compression, it is minus 228. Shear strength is doesn't have a sign, and it's 71. 71. Okay, and we don't have data for the other one. We don't need it. And this is pretty much it. Okay, save it. This is different from how I did in chapter 2, but it's an alternative way. That's fine. Okay, so now we applied our material, okay, and we are going to uh, go to the composite design workbench and basically apply our or create our zones. And we're going to do that based on the zone method, okay? So we go here to composite design, right there, composite design. Let me try it again. Back to me. Notice that a few times I tried to go to my composite design workbench, my favorite one, right? The composite, but it didn't. What it did, if you double click on it, it goes there, but under a new product. So the reason is that you have to go to the part first, right there. Double click on the part, so that you are not in the assembly design, and then you go to composite design workbench. Okay, so you got to be careful because when I tried to get into composite design, it refused. It opened up another file in composite design, but that's because I was not actually selecting the part file right here. Okay, I was in the top level assembly, but that's okay. We are good. We are in there. As you can see that down here, you can see that down here, the action pad has to do with composite design. Okay. So we're going to use the design zone design. So we click on the zone design, okay? And right here, this is a very important icon that we had before. It's called composite parameters. You click on it, okay? And you have to say add material. It goes to the library. Remember the material that you created and you saved it? You go there, okay. Now the question, where is it? So it is, we although I applied it here, but I cannot pick it there, okay? So what I need to do is I go to, okay, I still want to find that, so I can go to material definition. When you do that, it it shows you all the stuff that you have in the session right now. Right now in the session, I have this video chapter 3 composites. I'm going to select it, okay? This is the composite, this is for the covering, which is not really what I want, right there. Notice that what I did, instead of searching in database, what I did is I went there and I went to the material definition. As soon as I did that, it took me, it took me to, yeah, it took me to this material editor, and there's my material. I select it, and then it's going to populate that table right there. Remember, I changed the Q thickness to 0.75, right there. Okay, very good. Now, the next thing I'm going to do is create a rosette. Now, remember, I said that you can create a rosette later. I didn't create it before. You click on it, and it says add a rosette, and then I say put the cursor there, right click, and create it. So it's going to create one here at the global origin right there, which is fine for me. I don't have to. I always uncheck this current. It doesn't bother me. It's right there. Actually, you can see that the rosette is the coordinate system. Oh, let me try it again. I don't think I did it right. Add a rosette. No selection. Right click. Uh, create access system, and I say OK, and it is right there. I forgot to say OK probably. The rosette is created and it's right there. All right, so we say all right. Now it's created here. The next thing we're going to do, which is different in this particular problem, in this particular chapter, is I'm going to create laminates. I'm going to create 3 laminates, one with the thick section, one with the transition one, and one with the thin. So add a laminate. This is the color for material. We're going to use, there's two ways of creating laminate. I'm going to use this one, and then I select my material, and it's going to be, I'm going to try to type it in exactly like the stacking sequence that I had there, 90, add, and then another one, 0, add, another one, 0, add, and another one, 90, because I want to show you that this is all going to get jumbled up. Okay, so this is for laminate 1. This doesn't say where it's going to go. All I'm doing is creating it as I want it. And add another one, add another laminate, and by stacking sequence, material there's only one, and then that one I intended it to be 90, 0, 0. Say okay. It's two of them, and a third one by stacking sequence, material you select, and then it's going to be 90, and then 0, and then you say okay. All right, now it looks like, the directions are all the standard directions I want. The directions were 0 and 90, so it's already there, so that's right. Now, why don't we save everything first? Okay, all right. Okay, so now we're going to create our zones, okay? We're going to create our zones. So down here, you already created the parameters, and then it says zone group. Okay, I'm going to select 3 zone groups. Group 1, because I want to be consistent with this chapter. So it's going to be zone group 1, which is going to have only a single zone in it. Zone group 2 and zone group 3. Each one of these will have a single zone. You can do this thing differently, but that's the approach that I'm going to take. Zone group 1. Okay, look at what it says. The surface. This is the surface that I want, which, remember, it was called thick section, by the way. Thick section, okay? Rosette is properly selected. The draping direction is up, and that's pretty much it. Zone group 1, it's created right here. There is no zone in it. I can create the zone right now, as I have, I think, done in the book, or I can create all 3 zone groups and then do it one by one. So let me go ahead and let me see how it's done in the book. Let me see for a second. Yeah, I think in the book, immediately after I created my zone group, I'm going to create my zone. Here's the zone. Okay, this was zone group. This is zone. You click on it. Make sure this is zone group 1. Okay, because this, whatever we do, is going to go into zone group 1. It says the curve of the contour. Remember, I extracted these things. You can either put the cursor here and get it from the tree, from the tree or from the screen. If I select this, okay, it's the same as going to my part and selecting the boundary of the thick section. See that? When I select this, how it lights up, how this thing lights up in the tree, it's the same thing. So there we are. And for the laminate, well, we have 3 laminates. This is where I want laminate 1 to go. Rosette is already correctly selected, and we say OK. So notice that we created, first of all, we created zone group 1, and in it we have zone 1. Okay, and I'm going to repeat this thing. Although I'm creating 3 zone groups, that may not be necessary. It is not necessary, but I'll do it just like it's done in the book. So zone group 2, this is the surface, the transition section, and everything's okay here. And then I'm going to create my zone that goes with zone group 2. Okay, zone group 2. And for the boundary, I'm going to select the boundary of the transition section right there. See that it's selected? And for the laminate, I'm going to use laminate number 2, which is okay. And finally, zone group 3, which goes there, and the zone that goes in it, which is zone 3, boundary of thin section, right there, and laminate is going to be laminate number 3. Okay, save everything. All right, now we're going to make plies out of zones. Okay, now see that plies from zones right there, the icon here, plies from zones. You click on it. Remember, it says that you have three zone groups. So you want to make a plies out of what? Well, first we're going to handle zone group 1. The only thing that you do, you make sure that this says create plies without staggering. Even if you say with staggering, it will work, but it will give you a warning message. Okay, so we say okay. And notice that if you go down here, plies group 1 has been created, and in it there is four plies. These are sequences: ply 1, ply 2, ply 3, and 4, etc. Let's do it again. So we go to the other one, plies from zones. This time I want to do zone group 2, and you check that box. Say OK. Zone group 2 has plies group 2 has been created, and it's got 3 plies in it. It's got 3 sequences. Each one of them will have 1 ply. And finally, you click on plies from zone, and you select zone group 3. Make sure this box is checked, and we say OK. And we have all our 3 ply groups created right there. So we have ply group 1 having 4 plies, ply group 2 having 3 plies, and this one has 2. Now, if we can go and look at the ply configuration. So let's save everything here first. Okay. So if you go to under review, review, and there is a ply exploder. Scroll down. Ply exploder right there. It says you have three uh, ply groups. So which one do you want? Let's look at the first one. There. Okay. And if you look at the second one, there we are. And if you want all 3 of them at the same time, you select all of them with Shift key or Control Shift key. You see, they're all created, but the position of them is not right because we want a 90, 0, 0, 90. And in spite of the fact that I put it in that order when I was creating my laminates, when you do zone method, it does it according to its own algorithm, okay? So I have to change these things. Okay, now, to change these, although it's inefficient, but I'll show you how I do it because there's only 9 of them that I've got, how I do it. So I go and check every ply, not here, where the ply groups right there, and check the angle, see whether it's right or not. Okay, and it's easy to do it. So let me do it like that. So double click on ply 1. Okay, and angle, this should be 90. There is a more efficient way of doing it based on creating Excel spreadsheet, and you're going to have an Excel spreadsheet with 9 plies in it. You fix the angles and then import it back into the software. So that's not how I'm going to do that, but I'll do it in a different chapter in the book. So double click on this. This one is going to be angle 0. For simple problems, you can do that, but otherwise not practical. So ply 3, this is going to be 0 also. See how it rearranges this thing? And ply number 4 is going to be 90. Okay, good. Let's go to zone ply group 2, ply 5. That should be 90. See that? It changed. Number 6, ply 6 should be 0. The last one is okay. This is okay. And this last one is fine. There's no problem. You don't have to change it here. Okay. Save everything. All right. The rest of the problem is just like before. The finite element part is just like before. So what we do, first of all, let me get this, close all these branches, collapse all these branches. Okay. So we're going to go to structure model creation. Click on it. We are doing a, don't change anything here, automatic main bodies. Okay. Notice that no elements have been created, okay? Because if I had a solid object here, it would have automatically meshed it with some kind of an element, tetrahedral element. But because I don't have a solid object, it's not meshed. By the way, I don't like these plies. I don't like this explode the view, so I'm going to hide it. It's not efficient to do it one by one. What you can do is you can go put the cursor here, right click, and hide it. Okay, there we are. And even the zone, I'd rather not have it. I'm going to hide this. Okay, so this is just the geometry. All right, very good. Now, uh, we have two options, doing the meshing first and then assigning properties, or doing the properties first and then doing the meshing. I think in the book I have, let me make sure that I try to follow the same exact order. I think I have meshed it, yes. So I go here and I mesh it. Okay. So under mesh tab, I'm going to do a surface quad mesher. This is the one with triangles. This is the one with quads. That's what I want. And I'm going to select this. I'm going to do this one first, the thick section first. 5 millimeter the size here. Now, something that's very important is this capture, what is that? Capture nodes, etc. Now notice that because this is meshed separately from the other one, this is mesh first, this is second, third, on the seam, there may be duplicate nodes, some of them coming from elements on the right side, some of them coming from elements on the left side. I want these to be merged to each other, with each other. So what I do, I check this box, capture, and put a reasonable number here. I put any two nodes within 1 millimeter of each other, which come from elements on the two sides of this edge, are going to be merged, condensed, okay? And we say apply. And by the way, this is, I'm using a quadratic element here. There we are. So later on, if I look at the elements on this side, the nodes are going to be identical numbers, identical node numbers, so that there is no issue with running. So say okay. So notice that here it's created. By the way, I can change the color of this. Right-click Properties. I can change. Oops. Let me see for a second. That's not what I wanted. Put the cursor there. Right-click Properties. The color. Let me make it. I don't know. What am I making it in the book? Yellow. Okay, so I'm going to change this thing yellow. Easier to see. There we are. Now do it again. Surface quad mesh. For that one, quadratic, 5 millimeters, capture nodes within 1 millimeter of each other, and apply. There we are. Say OK. Can you change the color of that? I think I've changed it to pinkish. That one I did. Okay, and then finally, again, quad mesh on this last surface. Everything is the same. Apply or mesh. OK. And I'm going to change the color of this to green. You don't have to do that. It just looks nicer. That's all. not only nicer, it's easier to see that. And also, if you want, you can go and check the node numbers here, which is not as straightforward as you might think, but believe me, they will match. Okay, now we go to the properties. To go to the properties, by the way, if you don't want to see these things, right-click property, right-click, hide and show. There is the part. So you go to model right there. Go there, use the menu, model, and then properties, and then under shell, we need composite shell section. Composite shell section. Okay, this one. You click on it. Well, let's do it here. Let's do this one first. Thick section. Okay. Now we're going to do this thing. We can do it by different methods. I think I have done it by plies. Plies right there. See that plies? And it says that you have 3 plies. Which one do you want to do first? Well, ply group 1. Remember, this is associated with the thick section, which was ply group 1. I just want to make sure that this is the approach that I've taken in the book, and it is, yes. So we select this, double click on it. So it picks the right thing. Something very important, you expand the advanced and you select for offset definition the top surface. Okay, do it again for the middle one by plies. Sorry, that's not what I wanted. Let me try it again. What I wanted to do was this. Oh, support is that surface transition section, and by plies is the second one, and advanced top surface, and finally this surface, which is a thin section, by plies, ply group 3, and top surface. Top surface right there. Okay, notice that the 3 properties have been created here, right there. Well, this is pretty much done. So we are going to save this. And now we're going to go to scenario, structural scenario. Structural, well, it's a structural problem. All right. So notice that you have 2 red exclamation marks down here. That's because we have not specified a step and a procedure. So we go to the step, you click on the step here, and you have to select the final model. You select, there's only one here, you select this, and notice that when you say OK, immediately this thing changes to the green check mark. And then we're going to go to procedure. It's a static problem that we're doing. The only thing that we should do, we have to make sure that under the advanced, do not include geometric nonlinearity, because this entire theory is based on linear analysis. This lamination process, classical lamination theory, first order theory, is based on linear approach. We say OK, and this thing changes to green. So don't forget this linear step. Anything that you don't want to see, we can clean it up here. For example, there are different ways of doing it. One way is right-click, visualization management. Now I don't want to see my mesh, so you pull this thing down. So don't show me the mesh, just show me this. Now I'll keep this thing here. Now we're going to apply the load. Okay, so we go to the loads, and what you want to do is the force and shell edge load. You click on it. Okay, the support. Now I want to put it on this edge, but look, I can't pick it. Look, I can't pick it. The reason I can't pick it is that on top of this line sits all those plies and the sketch. Remember, I drew a rectangle in at the first step and then filled it. So I have to go and hide these things. Okay, so let me see for a second. Uh, so right now I can't pick. These are already hidden, so that's not going to cause a problem probably. But my sketch is sitting there. Hide it. Oh, there's more stuff. Oh, these boundaries maybe. Right click, hide. Right click, hide. Right click, hide. Let's see. Yeah, now I can pick it. Okay. So there was stuff sitting here. I had already hidden the stacking sequence. That's fine. Uh, but anyway, you have to hide the stuff until you can reach this. Okay. Now I want minus 10 Newton per millimeter. Minus 10 Newton per millimeter, and in the normal direction, and minus because this is like pressure. Positive is always putting in tension, and negative it puts it in compression. That's fine, and that's pretty much it. Okay, and same thing with clamp. So you go to restraints, you clamp. If you had not hidden those things, you would not be able even to pick that. This edge is clamp. Say okay. And these three edges are symmetry planes, okay, symmetry edges. So you use fixed restraint, these three edges, this one, and that one, and that one. We know that there is no displacement in the, for all three of them, there's no displacement in direction Y, and rotations are exactly the opposite. This is the stuff from basic symmetry for shell elements, okay? Uh, yeah. If you want to know have more detail on this thing, you can check the textbook that I have on. It's called Finite Element Essentials for 3D Experience. Okay, version 2021x. You say okay. All right, good. Save everything. We're almost done. Now we can go and run it. The only thing is that in composites, you want to be able to look at the stuff ply by ply on a ply by ply basis. So what you do when you go to simulate, the first thing that you have to do is ask for additional information, okay? Because if you don't do that, you won't be able to look at ply by ply. So you click on output. Okay, obviously you want stresses. I don't want these two. I just want the regular stresses. And then for damage or failure, you scroll down, you select failure, and there are different things that you can select. Saiwu is here. I'm going to select Saiwu. And if you want to check something else, perhaps some other failure, you can use these. See, all I want is Saiwu here, so this is fine. And now the other thing is that it says, where do you want info when you get this ply information? Where do you want us to apply it? Is it going to be the bottom surface, top surface, or middle one? Well, we're going to say, let me see for a second. Not here. Right, sorry, right there. Section points by layer, top, middle, and bottom. I just want to remind you, not all packages will allow you to select these things. Some of them are default. For example, CATIA uses default middle point. Okay. You say all right. So we ask for additional material. Now we're going to do some model and scenario check. No messages there. Simulation check. Run it. There may be one or two warning messages. You can check that yourself, but what I do is that if it's only warning messages, I'll go ahead and look at my results, see, and then I go and read the warning, which is a bad idea. But this is just checking stage, not running yet. That's good. And then simulate. Now this is where you need to pray. Run it. It's a very simple problem, so runs quickly. You can check any license messages. I don't think there will be any here, or maybe one here, I'm not sure. Tokens consumed, fine. And then if there are any iteration, this is a simple linear problem. There's no iteration in a single step. And then you can get the plot of, if there are iterations, you can get plot. In this case, it's linear, so just a straight line. Basically, there is no plots there. There. Okay. Well, first thing, let me close this. First thing is that, wait a minute, what happened? In other words, what is this? Well, this is step one. In step one, everything is zero. There's no load applied. If you go to step two, you see that you have this is a one Mises stress. This is an overall. It's not any particular level. My guess, and I'm not sure, but I'm pretty sure that what this is showing you is see, it says top and the bottom. If you rotate it, see this? If you rotate it, you see it, you can see the top and the bottom, and you go to these legends. But my point is that it just shows you the top face, which is the very top of these laminates. Okay, but it doesn't show you ply by ply. If you want to see ply by ply, you can go and, well, first of all, let me see. Right now, there's not much you can do here. Okay, if you look at the displacement, 2.58, by the way, which matches perfectly that reference that I showed you by Barbero's book. Now, if you want to see these things ply by ply, remember you ask for it. You click on the contour plot right here. You click on the contour plot, and you go here and say, okay, I don't want overall. I want, for example, I want to see the information in ply number one. Ply number one, which is, remember, it is at the bottom of the thick section. And I want to see the information only on the middle of ply number one. Okay. And what do I want to see? I want to see the one Mises stress, for example. Okay. And you say apply. It shows it to you. So there's ply number one, the middle of it, one Mises stress. Or you can say, okay, I want ply number 5, which was the bottom, very bottom of this transition section. And what do I want? I want the component of stress at the top of that ply. And what do I want? I want the shear, the shear stress is way at the bottom. Unfortunately, you can't reach it unless you select one of these first, and then you can reach it right there. I don't know why. And then, so this is ply number 5, the top face of ply number 5, and I want to see the shear stress in there, okay? And then you can say apply. There we are, okay? Now, incidentally, Let me say, okay, when you do that, then these plots that you generate actually appear in this menu, okay? And if you want any one of them, you can select it. So this is the first one that I generated, I think this one, right there. The shear one was, I think the last one that I did, it was this one, yeah. It actually gives it to you. I asked for the middle, but it gives you both the probably the top and the middle. Okay, this is the top one, and this is the top one, and this one is the middle one. Hang in there. Or maybe I just did both of them inadvertently at the same location. Okay, good. All right, folks. So the zone and laminate method helps you in some way, but you have to go and make sure that the stacking sequence is what you want. I did it ply by ply, make sure that the orientations were okay. If not, I changed it. Or the alternative is to export the ply orientations based on whatever CATIA has done, not CATIA, 3D Experience has done, and then go and make the corrections in that spreadsheet, and then save it, and then back import it, and it's going to work out fine. Good luck.